In water, acids give up a hydrogen ion or proton to the water molecule, forming a hydroxonium ion, H3O+. For example, hydrochloric acid produces the chloride ion and hydroxonium ion, acetic acid, the acetate ion, sulfuric acid, the sulfate ion. The amount of acidity can be measured on the pH scale, a measure of the concentration of hydroxonium or hydrogen ions, little p for power or strength, and capital H for the hydrogen ion. The pH scale is logarithmic, meaning that for each change of 1 unit of pH, there is a 10-fold change in acidity. To understand its logarithmic nature, consider this. You have collected a bucket full of acid rain with a pH of 4, and you want to make it less acidic for watering your garden. How much neutral water must you add to make the pH change from 4 to 5? Pause the video and think. Well, the answer is that you need to add 9 buckets of neutral water just to change the pH by 1 unit, since each change in pH is a 10-fold in acidity.
When an acid and a base react, the hydrogen from the acid will react with the hydroxide OH- group. This will form a conjugate acid and a conjugate base. The H plus OH makes H2O, which is water.
So let's try it in the lab. Here we have baking soda, which is sodium bicarbonate, which will act as our base. Here we have apple cider vinegar, which contains acetic acid, which will act as our acid. Now when we put these together, the acid and the base will neutralize and will form water.
An acid-base titration is an analytical tool used to determine the unknown concentrations of either an acid or a base. Here we apply the stir bar into the unknown solution in order to mix the solution well as we're adding the titrant or the known solution into the analyte, which is the unknown solution. We start the spinning so that that mixture will happen to completion. Then we add an indicator, which we've already added, which is why it has that pink color. And this will let us know the endpoint in the titration itself. We will start by adding large amounts at the beginning of the titration and can slowly go to less amounts at the end of the titration. This will allow us to be precise in determining the endpoint and equivalence point as when the color changes, because the color does change rapidly with an indicator. As we are doing this, we will want to pay close attention to the colors that are presented as more and more of the titrant is added to the analyte. Here we can see that we've had a slight color change to the red as we are nearing the endpoint. We will begin to only put in small amounts, drop by drop, while it mixes in and see if it will go to completion. As it gets closer, the color will become darker and darker, and we can see this as it gets closer and closer to the blue endpoint, and from there we will be able to calculate the equivalence point, and that will be when there are equal amounts of moles of acid and base in the analyte and in the solution.